Hello students, here's lesson 14, linear regression. Linear regression is related to bivariate data, that is, data associated to two variables. Remember, bi means two. Here's an example, a bivariate data associated to two qualitative variables. Here's an example. The same example we went through way back in week 2, or maybe week 3, I don't remember, some long time ago. Genders and majors of 30 college students, and we have two variables, gender and major, and both are qualitative. And too much information there, so we can summarize and reorganize accordingly and produce something like this, which we call a contingency table or cross tabulation. And from here, we can do appropriate counting and taking the ratio and so on and so forth to calculate the marginal distribution or conditional distribution, things like those. We went through these already, so let's move on. Now, here's an example of one qualitative and one quantitative variables. Consider this. It came from a class I had many years ago, and we have these, the assessment measures that I'm going to use for this class, exam 1, exam 2, homework 1, homework 2, and projects. Yeah, those are just nominal variables. So that's qualitative. Now for each category, we have all these numbers, and those are quantitative. And thus we can do various things, such as 5-number summary, or producing histograms, things like those. See 5-number summary and scatter plot. Did I say scatter plot? Excuse me, 5-number summary and box whisker plot. And then side-by-side histograms with appropriate color coding. Yeah. There goes an example of a bivariate data associated to one qualitative and one quantitative variables. Okay, so much for trivial cases. Now let's go to two quantitative variables. The same data set from the same class, but this time let's focus upon only these two. Exam 1 and exam 2, and momentarily forget about these. And instead of considering these exam 1 and exam 2 as assessment measures and consequently qualitative, just focus on exam 1 scores as one quantitative variable and exam 2 scores as the other quantitative variables. Alright? Do not look at these as a qualitative variable. Alright? Don't look at the assessment measures. Just focus upon exam 1 scores. Here, there's one quantitative variable and then another quantitative variable. And then we can pair them up. First pair, 57, 67. The second pair, 67, 79. Third pair, x, y. Another x, y. Another x, y, and so on. How many pairs are there? Well, there are 18 pairs because there are 18 students. And each pair, x, y, can be represented in a coordinate plane. If you do that, you're going to get this kind of visualization, which we call the scatter plot. This one. The scatter plot. Here, each dot represents a student. So for example, this student here, let's see, x coordinate is about 90, but y coordinate is about 70. So this student scored about 90 in the first exam, but in exam 2, only 70. Regressed quite a bit. And yes, indeed, the student. kind of like that. That kind of thing is called the scatter plot. And here's another example. And this one is a scatter plot for homeworks. Homework 1 scores, we have in X coded. Homework 2 scores, that's Y coded. Now here, let's focus upon these numbers, 0.60 something, 0.38 something. What are those? Those are called correlation coefficient. So correlation coefficient is about 0.38 something. And what does that mean? We're going to talk about correlation coefficient in a little bit more detail in the next section, but let me give you a brief overview. Positive R value means positively correlated, which means as I move to the right, the dots tend to go up. Do you see anything like that here? I don't know about you, but I don't see anything there. That's because R value may be positive, but not positive enough. Comparatively speaking, if you look at down here, then I get 602, something like that. And this is higher, and not coincidentally, this time I can see some positive correlation. As I move to the right, dots tends to move up. And then looks like there is a line of best fit going through in the middle like this, where my mouse is moving around. And then along that line, these dots are scattered around. And that line is moving upward, positive slope. Those kind of things are called scatter plots. Now, how do we work out these scatter plots? Let's discuss those in the next section, actually. In the next section, I have properties of correlation coefficient, but also the calculation problem as well, using MS Excel. So let's discuss all these in the next section. For now, let's just stop here. So much for section 1, bivariate data set. So we have two qualitative, one qualitative, one quantitative versus two quantitative, and we are interested only in the third case, in which case we get scatter plots.